Okay. Um, just one last thing. If you have not gotten into Hawks, I would get into Hawks ASAP. First of all, you're falling behind your assignments, and I know I'm going to be getting the email soon to verify if you're actually in class or not. So, since everything is done through Hawks in terms of homework and testing and everything else, it just makes it the easiest way for me to determine if you actually are coming to class or not. Because if you're not in Hawks, you really can't do what's required of the class. So, if there's any issues with that, just let me know after class, and we can work something out or figure something out to try to solve the issue that you're having. All right, so I will say that out of the first few units or chapters in this book, this section is probably the most confusing. Okay, because a lot of the terms, they're very subtle differences between things, and it can cause a lot of trouble, especially when you're doing the homework. This is one of those sections that typically has a lot of little issues and stuff with it. So, all right. So the first thing we're actually going to talk about the easy piece first: discrete or continuous. So, discrete and continuous only works with numerical values. Let's start with that. So we kind of talked about this a little bit when we were looking at the graphs, where I said you can't have a line between 2 points because the values don't mean anything. That's really was the difference between discrete and continuous. Discrete values are simple individual numbers, like 1, 2, 3, things like that. All right. Those would be discrete. So where there's an actual gap between the numbers. All right. Trying to think of things that would be like whenever you're doing counting, like, or if you're like figuring out how many books you have or how many days there are, things like that. Like those type of things are all going to be discrete types of values. Where on the other side, we have continuous. That's where every value has some meaning. Right? So if we're thinking about like temperature, so 95, 96, 97 degrees. However, between 95 and 96, there is values. And to get from 95 to 96, you have to go through every other value. To get from 5 books to 6 books, you don't have to do all the values in between 5 and 6. So books would be discrete, where temperature would be continuous. Most times you can literally say, can I have a half of something? If a half of something makes sense, it's probably continuous. Okay. I think the only example that I've come up with in all the classes that I've taught this with that doesn't work for is shoe sizes. Because you can have a half a shoe size, but shoe sizes would be discrete because you still can't, like, you're going to go from 9 to a 9.5 shoe and 9.5 shoe to a 10 shoe. The values in between don't mean anything. So that would still be discrete. But that's the only one that I can come up with that a half works that isn't continuous. Okay. Do those two values make sense? Like, out of all the ones we're going to talk about today, those are the two that are probably the easiest to wrap your head around. Both of these only work for numerical values, though. So if we're going to talk about like non-numerical values in a minute too. These only work with numerical values. So I can't ask you the colors and say, is that discrete or continuous? Okay, because that would be neither in that situation. So the only time you're going to have continuous or discrete values is if they are a numerical value. All right. Okay, now the hard part. And they made the words very, very close to each other, so it makes it even more confusing. Qualitative and quantitative data. We're going to talk about what the scales are, and that's next. But qualitative data, think about the beginning of it, it's quality. So they are qualities. So the color of your hair is a quality. That would be qualitative data. Okay. shoe size would be a qualitative data. Your social security number, your phone number, your ID number, those would all be qualitative data points. Right? Your grade, your like letter grade for a class, that would be qualitative data. Okay. Quantitative data, beginning of it, is quantity. So these are values that we can do some calculations and stuff on. So your age, your weight, your height, how fast a car goes, how much gas it uses. Those are things that would be quantitative data points because we can do some calculations on them. All right. So give me other than the ones that I've already given you, give me an example of qualitative data. Yeah. Yep. Okay. Give me another one. Not you. You already gave me one. Anybody.
Eye color.
Eye color. Something that doesn't have something to do with color. Give me any data point, and then we'll determine what it is. You gave me one already.
Weather data?
So weather data, there's a lot of pieces that go into it. So pick something that would be connected to weather.
Precipitation.
Okay. Would that be qualitative or quantitative? How much precipitation we got?
What about if it is or isn't? What about like sunny versus cloudy or something? I don't know.
So even those, like, you typically on the actual weather side of it, they never actually say if it's sunny or cloudy. It's an actual percentage of how cloudy the sky is going to be. So that's a quantitative data point. Because we can do averages, we can do calculations and stuff on it and those type of things. So that typically would be a quantitative data point. And then now you can see how they are really easy to screw up because they're basically the same type of work. All right, what's another data point? Air quality. Okay, so air quality, qualitative or quantitative? Okay, is it discrete or continuous? Because you're going to go through them all. Okay. All right. Okay. We're going to do more of these, don't worry. The rankings of 3 books on the New York Times bestseller list. Qualitative or quantitative?
Qualitative.
What is it?
Qualitative.
Why? Okay. So it's decent. Yeah, we could use stars and things like that. So it could be a numerical value. So the one thing I don't want you to assume is that if it's numerical, it's automatically quantitative. So you can have numerical values that are qualitative. So 3 stars, 4 stars, things like that. They're still numbers, and we can still like order them and stuff like that. But it still would be a qualitative data point. So, list of country codes that you must dial before a telephone number. So we never have to do this anymore because you don't have to dial the 1 before the area code and everything else like that. It's just assumed. However, if you're calling any other country, you have to add that in. So is that a qualitative or quantitative data point?
Thank you.
Qualitative.
Why?
There's no numbers in between. There's no like half step.
So that would be discrete between discrete and continuous. So yeah.
Because you don't have to calculate them, they're kind of set in stone already.
Yeah, it's just a numerical value for a country. So it's no different than me saying the United States or Canada or Germany, like those things. That number is no different than a name. in that respect. Okay. The height of 48 randomly selected female students.
Would it be quantitative?
Why?
You're taking like discrete points and like from your sample, and with it, you're getting a number out of it rather than like a quality of them. Like their height is a quality, but like
So what makes, okay, so heights would definitely be quantitative. So what makes a height quantitative where trying to think of, but the color of their eyes qualitative? You're all expecting them to answer, and they're not going to answer this time because I'm not going to let them. Why is height quantitative where the color of their eyes would be qualitative? Because both would be a quality of the person, right?
I mean, I guess you could, but.
We can, but yes,
Yeah.
normally we don't.
I
Depends on how deep you want to get into your science classes. So the big difference between those is actually what we're going to talk about in the next set of things. Can you do a calculation on it? Okay. So like a phone number is a qualitative data point of a person. It's the quality of that person. It is numerical. However, me subtracting your phone number from your friend's phone number doesn't give me anything to use. However, if I subtracted your height from your friend's height, that number has meaning. Okay. So when we're looking at qualitative and quantitative, sometimes we have to look at, can we do a calculation on it? Does that calculation make sense? Okay. And that's the next thing we're going to look at. Now you can start to see why I said this is the most confusing section of the whole thing. Levels of measurement. So there's 4 different terms of levels of measurement. Okay. You have nominal, ordinal, interval, and ratio. Okay. And as you're looking at these, they stack. So technically, anything that is a ratio is also an interval, ordinal, and nominal. All right. So when we're asking like to describe the quality of data, you're going to give me the best quality of data point. You're going to give me the best level of measurement for it. Okay. So you're going to see when we're talking about them how like kind of all add something on top of the original piece. Nominal. Nominal represents whether a variable possesses some characteristic or data that represents some variable of characteristics is a nominal. These are qualitative. So nominal data points are qualitative. This is where your colors would come into play. This is where phone numbers, social security numbers, those type of things would all fall under nominal. Right, hair color, eye color, what size shoe you wear, like those type of things would all fall under locks and that too, because we can do something else with those. So nominal is things that possess some kind of characteristic. Okay. Ordinal is one step above that. Ordinal is ones that we can put in order. So your rankings of the New York Times bestseller books, that's order. Even though it's still a qualitative data point, I can now put it in order, and that order has some meaning. Okay. So your shoe sizes and stuff might fall into this because I could put those in order and it would actually make sense. Okay. Your street address. I could put your street addresses in order. Like the order of the houses in the road actually has some meaning of where they're located. So in this case, they gave Frosty Props taste 1 very bad, 2 bad, 3 fair, 4 good, 5 very good. Like we can put those in order and that has some meaning to it. Okay. Although in today's society, everything gets 5 stars or 1 star. So it's funny. I read a thing the other day. It was talking about how Gen Xers are the absolute worst people on like Uber and those type of things because when we give a review, we view that 5 stars means exceptional service. If you just did your job, that's not 5 stars. But the way that all these apps and everything else works, if you don't have 5 stars, you're basically worthless to them. It's like, so we have a drastically changed what rankings mean. All right, so the first two, these two right here, ordinal and nominal, those are qualitative levels of measurement. So ordinal and nominal are both qualitative levels of measurement. The next two are quantitative. Interval is the first one. So interval data states that the difference has meaning. So like heights would be interval because if I subtracted your 2 heights, that number has some meaning. Age, if I subtracted your 2 ages, that number has some meaning. Can I put them in order? Can I put your ages in order, your heights in order, those things in order? Okay, so now you can start to see how even though you're an interval, it is still ordinal. And it's still a characteristic, so it's still nominal. Okay, so they kind of build on each other. However, when you're specifically looking at it, in this case, they would be listed as an interval data point. So temperature has some interval. We can do those calculations in it. Okay. The final one is ratio. Ratio adds in that we can, when you think of ratio, what do you normally think of? Gear ratios, 3-to-1, 4-to-2, things like that. They're typically fractions. Okay, ratio can be set up as a fraction. You can put the word 2 to it, the colon between it, but in essence, it's a fraction. So ratio is anything we can divide, and that has some meaning. Okay, so in this case, is money ratio. If you said you have $40, or your friend has $40, you have $20, that means your friend has twice as much money. That gives you some information. Okay, so ratio is that extra step to it. Not the one I want. Oh, I know. I can just do it that way. All right. Come on, give me the question. I'm gonna do a different question than this one. I'm going to actually use the one right from the Hawks assignment. So this way you can see how these are done, because this can be a little confusing. All right, letter grades on a math exam are examples of what type of data? Inferential, qualitative, parameter, or quantitative? There's a reason I'm using the Hawks quiz for this, because the hardest part of this assignment and stuff when people work on it is how they ask the question. Well, what's inferential? Did I even talk about that? No, I didn't. So it doesn't even exist. It's not even a value that you need to use. What's a parameter? Again, didn't talk about it. Not a type of data that we're looking at. So is this qualitative or quantitative? Why? Yeah. Letter grades. Okay. Letters just A, B, C, D, F, right? There could be a plus or minuses in there, but it is not numeric. Quantitative has to be a numerical value. Okay, so if it's not a numerical value, it cannot be quantitative. All right, so that's right there. Automatic makes it qualitative. However, numerical values can be either one, so that makes that piece a little more complicated. Next question. Somebody actually put there. We'll use that one in a minute. Goals scored during a soccer game are examples of what type of data? Qualitative, quantitative, inferential, or statistic? Well, we already determined nothing is inferential, right? We didn't talk about that one. So which one is it? Qualitative or quantitative? Why? So we could use so the difference has meaning, right? So would this be interval or ratio? Why? Can it be a ratio? The difference has meaning, yes. Does the ratio have meaning, though? So if I scored 4 goals and you scored 2 goals, I scored twice as many goals. Does that make sense, that statement? Yeah. So this actually could technically be ratio. And now you can start to see where it can get a little iffy, right? So yes, interval is absolutely correct. However, to be more correct, it would be ratio. Okay. All right, speed of cars on a highway. Why? Yes. The big key is to get from 60 miles an hour to 70 miles an hour, you have to go through every single value between those two. Okay? I can't jump from just 60 to 61 to 62. I have to go, it's a continuous scale right between those values. So that's continuous. Neither is a possible answer to these questions. Remember, we said that the value has to be numerical for it to be discrete or continuous. And it has to be quantitative for it to be discrete or continuous. So if you have a qualitative data point, the answer is neither, even if it would actually fall into what you would think of a numerical answer as discrete or continuous. Okay, so that makes a difference. Temperature in Celsius at different locations in an Italian city. Question 1, qualitative or quantitative? Okay, why? Okay. We can measure it. It has some, and we can do some calculations on it, right? Okay. So, quantitative. Discrete, continuous, or neither? Continuous. Remember we said determine that temperatures are going to be continuous. Okay? Nominal, ordinal, interval, or ratio? Yes. Why?
Because, I mean, I guess you could use a ratio as well, but typically people don't say, oh, it's going to be 1.4 times as hot there.
Okay. You added information when you said that, and that's the reason it's not ratio. So if I was going to claim it's a ratio, I have to do a division, right? But I can't say it's twice the temperature. I would have to say twice as hot or twice as cold. I have to give direction, which means I have to add information that I already don't know, that I don't have. So temperature is interval and not ratio. So you can start to see where those are the two that are going to be the hardest to be able to differentiate between. And those are the ones that are the easiest ones to mix up. So this would be interval. What about this one? What was it? Qualitative. Why? Okay, so this is qualitative. We're just looking at colors, right? Even though they have numbers in front of them, the numbers really don't mean anything. It's just how they made their list. Discrete, continuous, or neither? Why? Correct. This would be neither. Because it's qualitative. And qualitative is never discrete or continuous. Okay, since you've determined this is qualitative, which is the level of measurement.
B, no,
Why?
because it's not ordinal, like the categories don't have an associated order.
Correct. That's the difference between those two. Can I put it in order? Right. There's no set order. So since I can't put it in order, it is just nominal. So when you're doing qualitative, you're looking at those two values. Those are the only two ones that it could possibly be. When you said quantitative, that means it has to be either interval or ratio automatically. Okay? Those make sense? All right. Let's do another one. All right, this one. All right, what's this one? Qualitative or quantitative? What is it? Why is it qualitative?
Measuring the satisfaction rather than like numerical.
But I'm giving it a 1, 2, 3, or 4.
The other one had 1, 2, 3, or 4 too. This was 4 average, good, or excellent.
Okay. But isn't that no different than 1 star, 2 star, 3 star, 4 stars?
In this question, that's what-
Yeah. So I guess the question is does any of those situations I just mentioned make it quantitative? No. Okay. Just because, again, this goes back to the statement. Just because it's a number does not make it quantitative. Okay. It can be qualitative and still be a numerical thing. All that means is that it doesn't rise to the level of where I could do an interval or a ratio and actually do some calculations on it. So typically for interval, we can do differences, right? We can subtract them and make sense. So if you gave a 4-star review or 4 and I gave a 1 and I subtracted those, does that really mean a 3? Like that doesn't mean anything, right? So
If you're averaging, like if you're adding up the total ratings and then dividing that could be ratio.
So average doesn't necessarily mean ratio. Ratio means I'm looking at 2 different ones and actually comparing. So ratio means that I would take a 4, like I gave him a 4 and you gave him a 2. Okay, I rated him twice as good. Like that doesn't make sense. Like, because that's not the way those numbers necessarily work. So we will get into how we can do averages and stuff like that. But in this case, that doesn't really make much of a difference in this situation. So we can still, in this case, this is still going to be qualitative, no matter if it's a numerical value or not, because it's still that type of piece. So this is qualitative. Discrete, continuous, or neither?
Either.
Why?
It's qualitative.
Very good. This is actually one of the hardest. This right here is the hardest part of this one. It's like, okay, I see. And this one, yes, gives you poor, average, good, or excellent. But some of them will give you the number of stars. Some of them will give you the value. So it's really easy to go, wait, those are discrete values. Remember, if it's qualitative, it's always neither. You cannot Qualitative data is not discrete or continuous. Okay. All right, nominal, ordinal, interval, or ratio. Why?
Representing categories.
Yeah, we can put them in order. You can put the 4 stars above the excellence above the goods. You can put them in order, and that has some meaning. Is it making sense? All right, let's do one more of these, then I'll go on to. Yeah, before I picked the problems from the book, but I found the way that the actual Hawks asked the questions, it was a lot different. So it's easier just to pull them right from Hawks. The amount of monthly rainfall in 6 randomly selected months. Qualitative or quantitative? Why? Yeah. Yeah, we can do a bunch of different calculations and stuff on this, and it would make sense. That's typically what I use as the difference there. Can I do calculations on it? Okay, because that's really what interval and ratio has extra that nominal and ordinal don't. Is can I do some calculations on it, and that would make sense. If you say yes, it's going to be quantitative. Okay. Are these data discrete, continuous, or neither? Why?
All of the different numbers.
Yeah, like we got snow last night. It didn't instantly become 2 inches of snow. Although I went to bed and there wasn't a lot of snow on the ground, I woke up and there was. It still actually happened, even though I was sleeping. Nominal, ordinal, interval, or ratio? Yeah.
Ratio.
Why?
Because if you say, Norwich got 20 inches of snow and Groton got 6 inches of snow, you could like.
The ratio means something.
Yeah.
So, yes, the ratio means something. In this case, the monthly rainfall, I could say June was twice as wet as April, or vice versa. Actually. April's normally wetter than July. All right?
I have a question.
Yeah.
Would be discrete or continuous for this one? If it's 6 randomly selected months, would we have like singular data points?
You would, but monthly rainfall is still like rainfall totals are still a continuous value.
Right.
So that is a very good question though, when you're looking at it. Even though they said 6, you're still going to get 6 discrete data points, but the data you're collecting is still continuous type data.
Okay.
So yes. Oh no, it is interval. But remember what I was saying when we're stacking them. Ratio is higher on the level than interval. So because it's ratio, it still meets the criteria for interval. And it even meets the criteria for ordinal because I can put them in order. Ratio is just the highest level of measurement, so that's what we pick. It's ratio. Yeah. Yep. Yeah, it's almost like a pyramid stacking. Like technically ratio, anything that's ratio is also interval, is also ordinal, is also nominal. It's just it has all those criteria, so therefore it's the ratio, it's the one on the top. Just like ordinal and nominal, ordinal just says I can put them in order. It doesn't say it's not a characteristic. So ordinal is just one step above nominal. So you always want to pick the high. That's why it says the highest level of measurement. Okay. So, and sometimes you're going to get caught where it's like you click on one, it's like, wait, it is that. And they're going, well, it's also this one above it. So you have to look at those type of things. So that can happen. All right. Read this statement or read this little paragraph. All right, what are some of the data points we collected? Give me one. First one?
Type of home residence.
All right. So residents. So is it qualitative or quantitative? Qualitative. So nominal or ordinal?
Because they're arranged by how densely populated they are. City, town, rural.
Okay, but if I put, would the order actually matter in terms of what we're like? So city, town, rural, I guess you can look at like population density, but that doesn't necessarily mean the higher population. It's more dense. So does order have meaning? I guess is the bigger question.
You have to add meaning to it.
Yeah, we'd have to add something else to it. We'd have to talk about like population density or something like that there. So we'd have to add other information to it. So I would say this is just nominal. All right. What's another data point? Weight. I might actually do height and weight in here because they're both going to be the same thing in this situation. Qualitative or quantitative? Quantitative. So we're going to look at interval or ratio. You can say twice as tall or twice as as heavy. Those things. So I would go with ratio for these. Like that would actually have some kind of meaning and everything else in it. All right. What's one more? Income of the parents. Qualitative or quantitative? Okay. Interval or ratio?
Ratio.
Say somebody's twice as wealthy. Why do you think they should collect this data? Oh, actually, before I even go there, does everybody know what West Point is? Okay, West Point is the Army Military Academy. So these are basically where your officers for the Army, like all your generals and everything else, would have gone through West Point in the Army. All right. So why do you think they would need this data? Or why do you think collecting it's important? Huh? Yeah. Why does the type of home residence matter? Yeah.
Does it determine how likely they are to join the military? Or influence it in some way?
I don't know. I don't have a right answer for that question. That's a thought. Any other thoughts?
more like a city and county being revered.
Okay, so education level could vary. Okay. Anybody read this and notice something weird that we would think is very weird today? Why is that weird? What happened back in the 1800s? Father was the only one working. If you were a woman working, you were single and you didn't have kids. So most of them were teachers or nurses. So yeah, it's always one of those things like when you start to look back at things in history, it's like, oh, that's odd. Like it's just one of those things like today that like you'd have both. Like it does say the income of the parents, where it doesn't ask about the occupation of the mother. And in that situation, it was because of family wealth. Women typically could possibly bring family wealth with them into a marriage where that would have some difference in the income level, where it wasn't actual unoccupational wealth. So it's little things to think about and work with. All right. Last thing in chapter 2. Let's look at some graphs. So there's 2 different types of data that we can look at. We're going to look at a lot of data, but these are the 2 that they're talking about in section 2.3. It's called time series and cross-sectional data. So a time series is data that originates, is usually taken from the exact same process, spaced over intervals of time. So when you're looking at a time series, you're looking at one type of data point over time. Okay. So this was the American League batting championship or average. Is this a time series? Yes or no? What's the data point it's collecting? It's just looking at the global mean temperature, right? Over time.
But is it like each year? Does that matter?
That doesn't matter.
Okay.
So you don't necessarily have to have every single year. It's as long as the intervals are equally distant, it's fine. Okay, in this case, they're equally distant. So, all right. So here's one. Now watch this one. So we'll talk about how this is from the 1880s to today. So if we're looking at it, temperatures are going up. One thing. Should do this way. This is today. We're right here.